Hi and welcome to video 4, Angles of Elevation and Depression. In this video I'm going to show you and explain the idea of an angle of elevation and an angle of depression and how they're actually quite similar. And then I'm going to go through one example with you. And there are lots of different types of examples, but essentially they're the same. So first of all, you see I've prepared a diagram here. An angle of elevation or an angle of depression really define the same thing, and they are just references from a horizontal line drawn from your eye. You see this is my attempt at drawing an eye here. Now if you are looking, and we have our horizontal line here, which I'll call H, but you're actually looking up, then you are defining an angle of elevation, and that is your angle of elevation. If you're looking down at something, then you're defining an angle of depression. The trigonometry used to calculate unknown values, though, will remain pretty much the same, just we have a different name for them. So we have an angle of elevation and angle of depression. And here's a diagram for you below. This is just a mock-up of one particular context. This is one where somebody is standing on the ground and somebody is standing on top of a building. So here's our ground person, here's our building person. You can see that the person standing on the ground is looking up with an angle of theta at the person on top of the building, and the person on top of the building is looking down. And they have the same angle theta because they're horizontal lines, so the angle theta is reference to that horizontal line. Well, they're parallel, and we know from our work earlier in our mathematical careers that angles in parallel lines that are alternate, and these are alternate, so that's in the shape of a Z, well, we know that they're equal. So these two angles are equal, and often you'll find that there is a reflective property in diagrams between the angle of elevation and depression, and that they're equal. And so this person on the ground is looking up, and therefore they are defining an angle of elevation. The person on the building is looking down, and they're defining an angle of depression. So let's have a look at our example. George is looking up at a building and notes that the angle of elevation to the top of the building is 24 degrees. So here's George, and he's looking up at a building, which we'll put here. Now you can be a bit fancy, you can draw a building, you can draw a stick figure for George, or maybe something better than I can draw. But ultimately you want to break it down to a simple triangle. So I'm just going to leave it as George is here and he's looking up at a building. Here's the base of the building and here's the top of the building. If George is standing 50 meters away from the building, so that being 50, what is the height of the building and what assumptions have you made? Well, let's just start by making this a right angle triangle and calculating this height. The angle of elevation George has noted is 24 degrees. And using SOHCAHTOA and recognizing that our known values are the opposite and the adjacent, the opposite is not known, but it's what we're trying to find, I can see that this is going to be a tan problem. Tan theta is equal to opposite over adjacent. You'll notice that I always just write down tan theta is equal to opposite over adjacent. Start with the ratio, just ensures I don't make a mistake. So now I've got tan 24 is equal to h over 50. I multiply both sides by 50, giving me 50 tan 24 is equal to h. And of course, pop this in my calculator, I get h is equal to 22.26 meters. Is that reasonable? Well, if this is 24 here, well then our top angle there is going to be something more like 66. I expect 50 to be opposite a larger angle, so this is quite reasonable. Very happy with that. Now just verbally, let's talk quickly about the assumptions. So the assumption I've made first is that this is a right angle triangle. Now in terms of context, what could make that not be a right angle triangle? And the answer is these two sides, the two sides that make the right angle. So this one might stop it from being a right angle triangle. In this case, if the building is on a lean. Now, this is a fair assumption to make. It's unlikely the building will be on a lean, and if it is, given the building is still standing, it'll be an insignificant lean and probably won't have a huge effect on our answer. The second line that gives us a right angle is this baseline here. We are assuming that George is not standing downhill or uphill from the building. That would have possibly quite a significant effect, and there's nothing in the question to tell us that. So we could investigate this further by looking at what if he's standing on an angle 10 degrees down or something like that, and maybe just see what the effect is. But in this case, we'll just assume that he's standing on flat, level ground. The other assumption that really comes up quite a lot here is what is George's height? So if George is represented by that circle, then really the building height should be the height we calculated, 22.26, plus an additional little bit, which is usually, maybe we say George, we assume is 1.8 meters high. From eye level, maybe that's a little bit down, so 1.7 or 1.65. We don't know anything about George, so therefore we can't, we just have to make a general assumption on him being an adult male perhaps. So there's some of the assumptions work, and there's an example of a contextual situation. Angles of elevation and depression might be